And so I have this point here, this point here. So we have negative 3, comma 1. Over here we have 3, comma 1. Down here we have 3, comma negative 1. And over here we have negative 1, comma negative 1. Okay? And so what they want us to do for problem number 3 is they say, well, what's the perimeter? Well, you could do the distance formula for all the distances or lengths between the points, but you would have to do that for you'd have to do that like 4 times. Now some of these are kind of rigged up, which is easy. In other words, I could just count them. The distance from here to here is 1, 2, 3, 4, 5, 6 units. Okay? The distance from here to here is 1, 2 units. And the distance from here to here is 1, 2, 3, 4 units. This is the challenging one, right? So this one, we're just going to find the distance between those 2 points. So what I want to do is I want to think of this as x sub 1, comma y sub 1. And this one is x sub 2, comma y sub 2. And it doesn't matter which one we choose for 1s or which ones we choose for 2. The distance is the same. That square root, square thing, the formula that I'm going to write down will fix it every time. Okay? So it doesn't matter which points you choose. But to find the distance between those 2 points, the distance is equal to the square root of x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. All right? So now we just got to plug that in. So my x sub 2 was negative 3, right? So I'm going to say negative 3 minus x sub 1, which is minus 1. And we're going to square that. Plus y sub 2, which is positive 1, minus 1. Now, you're going to be tempted to skip, or you won't be tempted, it'll be just an honest mistake. Sometimes you'll forget that second negative sign. Remember, the formula has a minus in it. Yes?
Okay, I remember this mistake. That I just want to let you know.
That's okay. We'll finish this and we'll record the video, even though you may have figured it out already. All right. But what I was saying is that because the formula has a negative sign in it or a minus sign, never forget that. But then sometimes you'll have a negative number that you plug into the formula. Just write down negative, negative, and remember that when you minus a minus, it becomes a plus. So in my next line, I get that the distance is equal to the square root of negative 3 plus 1 is negative 2. Negative 2 squared is actually 4. Plus 1 plus 1 is 2. 2 squared is 4. So I have the distance is the square root of 8. Now 8 could be reduced, right? So if 8 could be reduced, how do I do that? Well, remember that when we reduce a square root, we look for perfect squares. So 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. But clearly, 4 goes into that. So I could think of this in terms of the square root of 4 times the square root of 2. That's one of the properties of radicals. Right? If I could take the number under the radical and put it into factors, then it's the same square root. Or I'm wording that wrong, but like you could take the product of the square roots. In other words, because 8 is divisible by 4 and 2, 4 times 2 is 8, I can break that up into 2 square roots. That means that I'm going to have 2 root 2 as an answer. What's the perimeter? Well, the perimeter is 6, right? It's 6 plus 2 plus 4. And then we just solved to find that this distance here was actually 2 square root 2. All right, so now here's another problem that we run into. How do I add that up? Well, if they did tell us to do a decimal, then we just leave it as that, and we would say that this is what we call the exact value. And so you add up the numbers that you can, that would be 12 plus 2 square root of 2. Because the square root of 2 is actually an irrational number. right? It never repeats, it never ends, it never terminates. If you were to put that in your calculator, you get 1.414 ... and it never repeats and it never ends.